All right, now that we've seen one example of exponential growth, I want us to look at another example of exponential growth. I want us to be thinking to ourselves as we go through this, when does an exponential model break down and when does it hold true? So we're going to start off with generations, right? We all have two parents, right? We got our own mommy and our own daddy. So this would be the number of ancestors that goes right here. Oh. All right, and then we'll put here generation. And so you go back one generation, you've got two ancestors represented. Okay. Let's also look at years ago. And we're just going to use the estimate of 40. It's just a nice round number used a lot, so I know it's not going to be exact, but we're going to just have 40 years, so 2020 equals 2020 minus 40, and then for each one we're going to go back another 40 years. All right, so that's generation 1. Generation 2. Right, it doubles. We can either write this as 2 times the one above, or we could write this as 2 squared. It's going to be the same number. Okay. All right, so let's keep this up, right? So we've got, this is your grandparents. Yep, we all have 4 grandparents. And then we all have sorry. We need to make this dependent on the number of generations. There we go. We all have 8 great-grandparents. All right, we go back one more generation. And around 1860, on average for us, of course, we'd have 16 ancestors. Kind of interesting to think this would have been a Civil War era. So while that was all going on, there would be 16 ancestors running around. So if you went back in time to see what was going on, you would have 16 people that you did not want to mess with, lest you return to the present to find that you do not exist. All right, so we go back again. Early 1800s, 1820, you'd have 32. Go back 6 generations, late 1700s, you have 64. So your number of ancestors, you have doubles with each successive generation back. And so you keep going, let's go all the way back. So if you're, somewhere in here, say you wanted to see Columbus sail the ocean blue, well, you'd have 16,384 ancestors running around at that time. That is a lot of ancestors. Okay. And so let's continue our journey backwards in time through the generations. Let's go back to the start of the previous millennium. So at the start of the previous millennium, there would be about 67 million ancestors running around. It's a lot of ancestors. Let's keep going back even more, right? Lots and lots of ancestors. All right, let's go ahead and stop here. So at 420, it looks like you would have, let me make sure I get this right. Yeah, about 1 trillion ancestors. Now that's bigger than the current population, It might even be more than human beings that have ever lived ever. But what's going on with our model? I mean, surely every time we go back, it doubles, because, our parents had 2 parents each, then they each had 2 parents, and it keeps going back and back and back. What is happening? Why do we have so many ancestors when there's not that many people? And I'm sure almost all of you have guessed the reason. At a certain point, all our family trees branch back in onto each other. Hopefully farther back than recent, but that would be where this model breaks down, is that it's not always doubling. And so that's something that you have to keep in mind with the exponential model. Something at some point has to give.